So we're going to keep with our topic in around creatine, around roles in the brain, which has got a lot of attention recently, a lot of discussion around this. As some of our experts have alluded to, there is some interesting work that this may be based on, but we also need to give the appropriate context and nuance with it. So maybe to kick us off, Professor Phillips, can you let us know why this has become so interesting? Why are we now seeing research emerge, trying to look at some brain-related outcomes and creatine? Where does this link come from?
I think one of the things that we've begun to realize is that brain decline is actually an energetic phenomenon. And so I think some of the things that have applied that Dr. Helms described for muscle with energetics and creatine are now being applied to the brain. And the brain, like the muscle, stores phosphocreatine. And the thought is that maybe creatine can help buffer some of these energetic stresses that happen in the brain and help with cognitive performance, maybe even chronic brain disorders like dementia and Alzheimer's. So really exciting area, because remember, these are things that we don't have drugs for. This may be an area where I think, as the most senior person on the panel, I have a tremendous age-related interest in this, and I will not wait for the clinical trial. So like Dr. Helms, and I'm not concerned about baldness either, I take creatine, and it's one on my supplement shelf for that very reason.
So, Dr. Helms, maybe we can speak to more of some of these outcomes, because when we take a topic like brain health and we consider creatine, brain health is so wide. We can look at things on a very acute level, like does it impact our immediate cognition, or does it have something long-term like Alzheimer's risk reduction, or somewhere in between? Can you maybe give us an idea of what things maybe have been looked at, what areas maybe have more work or less? What is the kind of lay of the land?
Talking about more work or less, the robust study of creatine as a muscle performance supplement started in the 90s primarily. And so we've got 30 plus years of data on what it does, why it does it, how it does it consistently, and whom. You know, vegans might benefit more, all kinds of interesting nuance. But it would be another 10 years before we started seeing the first studies on, you know, the brain function and response in the brain and brain physiology as it relates to creatine. So we don't have as much data, right? And it's also not it wasn't the main focus in the 2000s. It was kind of like the side research. But now that there's interest, that the way research works, we can get more funding. We're able to recruit. You know, it's a health thing rather than how do we make athletes, you know, slightly faster. So being able to do this research is probably going to start snowballing forward. So even though I don't think we should be waiting to get the potential benefits, because there's no downside, and you'll forget to take it pretty soon if you don't take it in the first place, I think we are going to see an explosion of research in this area. And we are seeing an explosion of research in this area. The physiology is the interesting thing, though. You've probably heard of the blood-brain barrier. We're always like frustrated with certain drugs or compounds. We can't get it across the blood-brain barrier. It's probably a good thing that things don't cross the blood-brain barrier that easily. We don't store that much creatine in the brain, but it does store it. And we can't get as much into the brain. So you're typically seeing, you know, I was kind of poo-pooing loading earlier, but when you look at dosages that might benefit the brain, you kind of have to overcome some of these barriers. So even though it's storing less, to make it actually reach the brain, we probably have to take higher doses. How much that is, we don't know yet. And I think it's also important that we shouldn't just view creatine as just brain good. The data doesn't indicate at this stage that if you take a young, healthy person who is not undergoing any kind of cognitive stress, injury, or disease state, that there's going to be any benefit from taking creatine. Maybe that'll come out of the data, but it's currently not there stating that. What we do have is things on sleep deprivation. In a sleep-deprived state, there's potentially an acute benefit of taking creatine. We have other situations where potentially, brain injury or some of the things that, Dr. Phillips mentioned. So it's an emerging area. We don't know what we need to do to maximize dosing or even get the best benefit out of it. It is definitely an interesting emerging area that we need more research in, and I think we're going to get it.
Speaking of that, this is where we have this really interesting application now in sport and in around where we have these situations where there's a challenge for the brain in getting substrates, or in those situations, not only of sleep deprivation, but after, as you mentioned, a brain injury. One thing you said earlier, Claire, and I thought was a great line, is that working in elite sport, you don't have the luxury of waiting around until we get confirmation of all this stuff. But there is something that a lot of organizations are using at an elite level of in specific contexts, not prophylactically for everyone, but in a specific context like a concussion, for example, it could be used. Can you maybe speak to your experience of looking at this, maybe thinking about these types of applications in sport?
Yeah, so I've loved the descriptions of the potential link between creatine and the brain. And even we know in, let's say, traumatic brain injury, or as you say, concussions, the brain's essentially in an energy crisis. The brain is not functioning the same as without concussion, and it's struggling to essentially repair itself, let's just say. So there are a few protocols that we can use. Some of it, like you said, isn't fully there yet that we know this exactly does work, but there is nice emerging evidence, one being around creatine to support the recovery post-concussion and in that recovery period. So by increasing a loading dose to an athlete in that initial stage of the recovery from a concussion in like the initial 5 days, and then continuing with a maintenance dose for that kind of the rest of the concussion, like RTP phase. So that could be maybe 8-9 days if they're not already taking creatine. That's kind of one strategy used, and it can potentially might help reduce symptoms. So alongside a concussion, players or athletes in general can symptoms such as like headaches, sleep could potentially be impaired. So we try to basically use a holistic approach to try support these symptoms, and another one being alongside potentially antioxidants, anti-inflammatory type ingredients to try support that reduction in inflammation or oxidative stress that might be happening during a concussion. Another one of that is like around the sleep hygiene. If sleep is impaired during a concussion, there's headaches, etc., you're trying to basically go after it with a holistic approach, not just your creatine, but you basically have like a concussion protocol, one being creatine, one being around using maybe more flavonoids, antioxidants, that kind of anti-inflammatory stuff, extra really ramping up that kind of fruit, veg. Alongside then, I mentioned earlier around omega-3, some potential emerging evidence similarly around that one, really ramping up the dose of omega-3 supplementation alongside oily fish, your salmon, mackerel, sardines even, to help pull back that kind of inflammation that's happening. There is a challenge again alongside that, high dose of omega-3 with athletes. Sometimes I can't even get them to take one. So often the capsules can be quite big, so that can be challenging. So it's just trying to find a strategy that works. And the other one, as I said, I haven't even mentioned, with creatine, sometimes you see an increase in energy requirements. So often athletes who are concussed, they will reduce their training. So they can't train. They might be doing a bit on a bike or whatever and slowly ramp it up. So they often think, I need to basically skip meals or skip snacks or really pull back on energy intake. But actually we know the brain requires energy, that you still require those meals and balanced snacks and your protein intake to get these antioxidants and these kind of oily fish, etc. So we still need a balanced approach. So it's kind of an overall concussion protocol. As we said, we don't know the exact of what exactly should we be doing and what dosage and what timings, but we're trying to basically do all we can to try speed up that recovery period, reduce symptoms and support overall health and recovery.
Especially in the context of, as you mentioned, importantly, no downside. That's obvious from ramping up creatine for 4 or 5 days post-concussion. There's no real downside. Professor Halson, I wonder, could you speak to some of the evidence we may have or different investigations that have looked at these types of applications within sport, or when there is an energy crisis post-concussion or a TBI? What has actually been looked at to this point, or what is underway? Can you give us an idea of the evidence in this space?
Yeah, there's not a great deal of evidence. The space that we've been working in is around mental fatigue and understanding that athletes, we've finally worked out as physiologists that athletes have a brain. We've spent our life in the periphery and we're like, we might need to pay attention to what's above the shoulders. Some of the work that we've been looking at around mental fatigue has really been around trying to understand how it occurs, why it occurs, and then what you might be able to do about it. And some of these strategies kind of fall into that space. So there hasn't been a great deal that I've seen specifically in sport around things like creatine in athletes. We've talked about using it for mental fatigue as one of the potential strategies, because obviously the brain needs fuel, but it's spoken about, but there's not a huge amount of science yet in that space to talk about it. But yes, around this, if you've got potentially some kind of dysfunction, whether that's excessive mental fatigue, whether that's sleep deprivation, athletes are all sleep deprived, maybe things like creatine can be helpful.
And I think this is a crucial point we'll probably return to later, that to make that distinction between generally the average person that is healthy and adding a supplement, whatever it is in that case, versus a situation where you're trying to get someone back to a baseline, and you can see different effects there, which probably play out. One of the things that I hope you can comment on, Professor Phillips, is if we return to this concept around what is going on with aging as to why creatine is being used. You've already alluded to some of this. Can you maybe just go in a bit deeper on some of the things that is occurring within the brain at that point, and why is it that creatine could, if we do see these benefits that are proposed, that the role it could potentially be playing?
Yeah, I think that the key point is to realize is that age-related cognitive decline, dementia, and even Alzheimer's-related dementia we're now beginning to realize, we used to think that it was sort of tangles and plaques, and we used to talk about tau plaques, but is probably related to mitochondrial function. So mitochondria, just a quick biochemistry crash course, is the organelle inside a cell that generates energy. And when it doesn't function properly, phosphocreatine acts as a buffer. Energetic crises inside neurons happen, and if you can support them, in a sense, then with more creatine to give more phosphocreatine, maybe you can buffer them against some of this mitochondrial dysfunction, slow decline, or maybe even in some cases transiently reverse it. I don't think it's a cure per se, but again, just to remind everybody that we have no good drugs to treat any of these things. So prevention is the best strategy. Eat well, exercise, that sort of thing, and good sleep as well. But I think it's really, we're beginning to realize that mitochondrial dysfunction is a key and core component to a lot of those syndromes. So creatine is, to the rescue once again. And low investment in terms of money, high payoff in terms of alleviating something for which we don't have a good treatment.
Dr. Helms, you mentioned earlier that we have multiple gaps maybe in this research. We see lots of promising things, but we don't have exact answers to some specific questions we like. You mentioned dose as one example, or even the impact on certain outcomes. For us to get to that point, what are some of the next research questions you think would be most important that we try and get answers to that would move us along this direction?
Great question, Danny, because this gives you insight, everyone here, and all of the people who you try to serve, as to what types of evidence should you look at broadly when you want to have answers to questions. So for concussion or TBI specifically, what we currently have is animal model data. I'm not saying I'm a fan of this, I'm saying it has happened, where we actually give animals a brain injury and then give them creatine and say, oh, they're not as messed up. And then we have some limited data in humans, but certainly not enough where we've used it in the interventional nature or observational nature. What we really need is more long-term research where you take a cohort where you know they're probably going to be getting TBIs, contact sport, and you observe those who are and aren't taking creatine over long periods of time. And I think we need more mechanistic research to try to determine, well, okay, so how can we measure creatine in the brain more effectively? Obviously, we can't be invasive in that part of the brain, but we're getting imaging technology that's getting better, functional MRI, trying to find some biomarkers that might be able to assess that, and getting a better understanding of, to the level we have with muscle. Like, we know how long it takes if you're taking a maintenance dose to reach muscle creatine stores that are the same as if you did a loading phase. That's the type of granularity we need to where we can understand how do we overcome some of the bioavailability issues of getting brain creatine stores higher, so we can get a dosing protocol, so we can do some trials, prospective cohort studies. And once we have that, now we're cooking with gas. So I think that's where we want to get to ultimately. But again, just to reiterate, there's no downside here. The beauty of coming to brain research late in creatine's life cycle as a studied supplement is that we have safety data. If this was something that was harmful for brain health or some other type, you knew it would have popped up in the last 30 years. So I think the good news is you could take it without much issue. Again, the only thing is that because the doses that are currently being recommended are close to what is recommended for loading protocols for muscle, people can potentially anticipate that if they're really pushing those doses, they may perhaps sometimes be at slightly higher risk of GI discomfort. And you can do some things like taking in lukewarm water, splitting up your dose throughout the day, taking it with food, the things that will have historically helped people with the actual, loading protocols that you don't need to do, but now you're maybe half that if you're trying to get the higher dose that we think might be necessary for brain health.
And I guess the key point for maybe a lot of people here who will be communicating messages to their audience, to a wider group of people, is that it's one thing to say there are potential benefits, there's no major downside. Even beyond that, if it didn't have some of these benefits, we know it's going to be useful for other things like your training. So it's probably a good idea for people to be consuming that. That's one message that's very distinct from everyone needs to take 30 grams a day because you'll have way better cognition. And we don't necessarily have the evidence to say that thing. So distinguishing how we're communicating what is there make a big difference. I'll give each of you a moment to give, again, one of your key takeaways on what we've discussed in this particular session that you would most want to leave people with. And maybe this time I'll start with you, Claire.
I would say for any athletes who are not in bodybuilding, weightlifting, those kind of category sports, more team sports, or also practitioners working in these sports, I would say use performance language around creatine versus the kind of the muscle effects, because we know it's beneficial in many different ways. And if you are struggling to get buy-in with athletes, use the language, for example, in a team sport. Are you trying to go after repeated efforts or sprint or speed, etc.? Using that language will help to get the buy-in into taking it.
Fantastic. Dr. Helms.
I think I've got enough concluding remarks, but one thing on the same topic as protein is when you're working with athletes who hear maybe creatine comes from animal-based foods, they might think, oh, then I can't take creatine if I'm vegan or have certain religious restrictions. But creatine is actually generated in a lab. We don't need very cheaply as well. So it's not an animal product. It is technically vegan. So it is something that is a good idea, even more so probably for vegetarians and vegans who would have a lower dose. And there is one classic study that found that vegetarians and vegans benefited more from creatine, from performance, than omnivores. So that's a little aside, but I think they can cover the rest.
Yeah, I think for me, it's making sure that we're recognising that mental fatigue in athletes is of interest, it's occurring. We need to explore ways to try and mitigate that mental fatigue and understand why it's happening. And I think potentially creatine could be something that's interesting in that space, but let's just not neglect that athletes have a brain, they do some cognitively demanding tasks, and that their brain can get tired just like their muscles can.
I have a short supplement shelf, and I hate to admit that in this forum, but creatine's on it.